Hello everyone. Today's lab is Lab 1, Diodes. We're going to be learning the basics about diodes and rectifier circuits. So from what you've learned in class, this is the ideal diode equation here. ID equal to IS exponential VD over N KT over Q minus 1. And that can be approximated during forward bias as this expression here, where I've gotten rid of the minus 1. Because when you're in forward bias, this term is much greater than the minus 1. So this is very, very accurate when forward biased. So this pre-lab has a couple parts to it before you get to the simulations. The first part is asking to give approximate values for IS and N. So if you were to look at the data sheets, you might find some information about IS, or you might be able to figure it out from some of the plots that they provide in the data sheet. N you might not be able to figure out on your own without some extraction of some of the plots. So for this pre-lab, we're just asking you to give approximate values based on what you've learned in class, or some approximate ranges. So just give some range for N and IS. Doesn't have to be perfect, but is IS microamps, 10 microamps? Could it be nanoamps? What kind of levels are you expecting? And similar for N, what range of values would you expect for N? The next part of the pre-lab asks you to, given some ID versus VD data that we're going to extract in the lab, how would you determine N and IS from the data? So let's make a little plot here, which you've seen in class or in your textbook, where we plot ID versus VD. Current through the diode versus the voltage across the diode. And we could extract that in the negative direction as well, since you can reverse bias the diode. And we'll call that 0. And if you plot this, it should look like an exponential function based on that equation that we have. And it goes into the negative direction as well, and eventually you break down the diode and it looks something like that. But we're going to stay in this forward bias region for this lab. So if we get some data points on this plot here, which is what we'll do in the lab and for the simulation maybe, we want to use these multiple data points to figure out N and IS. So there's a few different ways to do that, and I'll go over some of them, but there's probably others. The first one that you might have learned in class involves using 2 data points. And if you write out this diode equation for 2 separate data points, you would have ID1 equal to IS, which is a constant, exponential of VD1 over N KT over Q. And your second data point, ID2, is equal to IS exponential of VD2 over N KT over Q. If we look at these 2 equations, the only variables you don't know are N and IS. So you have 2 equations, 2 unknowns. You could solve those for either N or IS and then plug back in for the other one. So that would be one way to do it, just involving 2 data points. Because you're only using 2 data points, this might not be super accurate. Another method we could do is, which also might not be very accurate, if we look at this equation here, when VD equals 0, exponential of 0 is just 1. So ID equals the IS when VD equals 0. So I'll write that down as the second method. At VD equal to 0, ID equals IS. So if we look at this plot here, VD equal to 0, that right there would be equal to IS. So you would get IS from that, and then you could plug into the diode equation with any of your other data points, and you could figure out N. So that's your second option. There's a third option, which I'll mention. If we have multiple data points and we plot this in Excel or MATLAB or something like that, we could get a best fit exponential function, which would be a e to the bx, or some form like that. So if you get that function, so best fit exponential function. So if you have a e to the bx and you get good precision on a and b, you can equate that to a would be is, exponential b would be 1 over n kt over q, and in this case x equals vd. So if you have the a and the b terms, a gives you is, b gives you 1 over n kt over q, you can solve for n. And that would be your third method of obtaining N and IS from experimental data. And there's probably others, but these are the three that you've either seen or are more intuitive. So that's it for the hand calculations or theoretical part. The next part of the pre-lab is to do some simulations.